Hello, grade 8s. Today I asked you guys to play with the simulations to look at the lenses. And the first one I want to go over here is the convex lens. So a reminder, the convex shape is one that's wider in the middle and narrower on the edges. So it creates kind of this pointy oval shape. Now we know that when light enters a lens, it's going to be something dense like plastic or glass. It's going to have to bend the light, but it will bend the light differently depending on what part of the lens it hits. So we're going to have this candle here, and it's going to be producing light, and we're going to see how that light moves through this lens. So I'm going to move it over to this F point, and this F point, we'll see how it changes. And right away, we already have some problems, but we will notice first of all that light is scattering from the candle in different directions, and when it hits the lens from this F point, everything goes straight, which is pretty cool actually. So we notice that light bends and it keeps bending in towards the middle. And what you notice as well here is that the light will kind of all bend the same general direction. Now this F point is the focal point, so this point is forming a really zoomed in image. You see down here 150 times zoom, which is pretty massive. So we're going to move it back here to this 2F point and see what happens. Alright, so we see the light still bends inwards, but because the light has further to go, it's hitting at greater angles, it's going to also bend at a greater angle and refract that greater angle. And this 2F point is going to be the point where we form an image that's the exact same, but just upside down. So here at our focal point, we see a new image formed. And as you keep playing around, you'll notice the light will always scatter different directions. If you get a little bit closer to it, we'll form a bigger image. And this is how our microscopes at school work. Our microscopes at school are a series of convex lenses, and the closer our eye gets to the optical lens, the bigger the image gets. So that's why as we get really close, we start seeing bigger and bigger images formed. To the point that we really can't see anything, but you see our magnification gets very large. On the flip side, if we have our candle really far away, you notice that our image that we can see gets very small. So depending on where you are with the focal point, moving back and forth can make your image really large or really small, but it will always be upside down for the image that you see. And this is also why it works with our microscopes. So I hope that helps you guys understand lenses a little bit more. Feel free to play the simulation all you want, but I'd like you to notice these things. Next video up is the concave lens, so please make sure you're watching that because that has some cool parts to it as well.